In this video, we're going to learn the standard equation of a circle and how to graph that, as well as figuring out different ways to solve problems using circles. The basic equation of a circle is x squared plus y squared is equal to r squared, or radius squared. Now we use this equation when we have the center of the circle is going to be at the origin, or when it's going to be at the point 0, 0 on a graph. The r squared is our radius, and so r would have to be figured out by taking the square root of the value. So for instance, if we have the equation x squared plus y squared is equal to 16, we would know that if we had a graph of this, we're going to have the center of the circle at the point 0, 0. Now our r squared is going to be equal to 16. This is r squared here. So we have to take the square root on both sides to figure out the radius, which would be 4. When we would graph this, we're going to have 4 points on all of the axes, 4 away from the center of the circle, which is at 0, 0. So if we graph this, we're going to have a point here, 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 and here. We graph this as a circle, and it'll look something like this. The standard equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Now this differs from what we saw earlier only with the inclusion of h and k. That will actually denote what our center is going to be for the circle, where we have h and comma k. You'll notice that there's minus signs in front of this. That does not translate into the center of the circle. So if we have a minus sign in our equation, it'll be a positive value in front and vice versa. If we have a positive here, it'll be a minus here. Again, our radius is going to be the square root of r squared, so our radius is r. So if we have an equation, say, of x minus 3 squared plus y plus 4 squared is equal to 25, what that's going to tell us is that the center of our circle is going to be at point 3 comma negative 4, and then our radius is going to be the square root of 25, which is equal to 5. If we were to graph this, we're going to put a point at 3 comma negative 4 for the center of our circle. What we can end up doing is from the center point, add 5 on all directions. So we'll have 5 here, we'll have 5 here, we have 1, 2, 3, 4, 5 at top, then we have 1, 2, 3, 4, 5 here. So we'll have a point here, here, and here. With that information, we can draw our circle. Sometimes you'll receive an equation where you're given just the center of the circle, which we'll say for this example is going to be minus 11, comma 17, and we're given that the radius of this is going to be 14. With that information, we will have to use the standard equation of a circle to input in those values. And so we'll remember that the center of the circle will be h and k, and our radius will be squared to get r squared. If we plug these values in, we're going to get x minus a negative 11 squared plus y minus 17 squared is equal to 14 squared. Simplifying this information, we're going to get x plus 11 squared plus y minus 17 squared is equal to 196. When we have equations like this and it's telling us to figure out the equation of a circle, what we can do is something called finding the perfect square. So we can group our x values over here on the left. We'll group our y's nearby to just reorganize this. And we're going to move this 9 to the other side. So we're going to say equals to negative 9. We want to have the groupings of x and y next to each other, but on the left side of our equal sign, and all numerical values on the other side. Once we have this, we can figure out perfect squares. So a perfect square is going to be a number that's half of this value we see here. So it'd be minus 3 because we have a minus sign in front. And then we would square it. Now if you remember, x minus 3 squared would give us a value of x squared minus 6x plus 9. Well, we have the first two components. We have the x squared, we have the minus 6, but we don't have a plus 9. So for us to complete this square, we're going to have to add a 9 on this side, which then will complete this square. But if we add 9 on this side, that means we also have to add 9 on the other side. Now we'll do the same thing for this one here. We have y squared plus 8y. So we can take half of this 8 to get y plus 4, since we have a plus sign in between, and we would square that. We can look at just this last value, which is 4. 4 squared would give us 16. So if we add 16 on this side to complete this square, it would mean that we would have to add 16 on this side to complete that square as well. Now you notice that it is just the squared value of the last component, so 3 times 3 will give us 9. 4 times 4 will give us 16, and we can do that for all values like this. Now we can simplify this out. 9 and negative 9 cancel each other out, so we're going to be left with x minus 3 squared plus y plus 4 squared is equal to 16. This would tell us that the center of our circle is going to be at the point of 3 comma negative 4, and that our radius is the square root of 16, which is going to be equal to 4. With the standard equation of a circle, we can also solve for word problems. So for instance, we have a drone can fly within a 10-mile radius of its launch point. If the launch point is at negative 7, 2, find the equation of the drone's flight zone. Later, the drone reaches a point of negative 2, 10. Determine if that is still within the allowed zone. So we know that from our standard equation of a circle that we have a center here of negative 7, 2. We also are given that the radius is equal to 10. Well, we remember from the standard equation, we're going to have x minus a negative 7, so that'll be positive 7 squared, plus y minus 2 squared is equal to our radius squared, which will be 10 squared, which is 100. So we have the standard equation of our circle. Now we could graph this, and what it's going to look like is something similar to this over here, where we're going to have a point of 2 and negative 7, which would be around here or so, and we would have a 10-mile radius for a value, and now we need to determine if that point negative 2, 10 is going to be within the circle, outside of the circle, or actually on the line. To determine that, what we're going to do is we're going to take this point and we're going to plug it into this equation here. And what we want to see is that the value that comes out of it is less than or equal to 100. Because the value that is determined from here will actually tell us from the center of the circle, which is here, whether or not what the value of that radius is from that point to here. So if it is less than 100 or less than a radius of 10, we'll actually know that it is inside the circle. If that value comes up exactly as 100, we know that it is right on the circle. And if it's greater, then it would be outside of the circle. So plugging in those values, we're going to have negative 2 plus 7 squared plus 10 minus 2 squared. Simplifying that information, we would get 5 squared plus 8 squared, which is 25 plus 64, which is equal to 89, which is less than 100. So therefore, it's within inside the circle around here. So yes, it is still within the approved zone.